Hello everyone, my name is Arunima Dasgupta and I am currently pursuing MSc in Clinical Embryology from Lovely Professional University, Punjab. So today I am going to talk about Mega Software. So you can basically download the Mega Software from your PC, laptop like that. What is Mega Software? So first we need to know what is the full form of Mega Software. The full form of Mega Software is Molecular Evolutionary Genetics Analysis. So Mega Software is a computer software used for statistical analysis and construction of phylogenetic trees. So first, here in this software, we can align the genetic sequences in a proper manner, and finally the aligned genetic sequences can be finally used for construction of the phylogenetic trees. Now the question arises, what is phylogenetic trees? So basically the phylogenetic tree is represents the evolutionary descent of organisms from a common ancestor. So it is used, Mega Software helps in construction of the phylogenetic trees, and through that we can see that what organism are more similar genetic in a genetic manner, uh, which organisms are more similar and which organisms are less similar. So the in the following video I will show you how to download the Mega Software and how to use the Mega Software. So this video will be a little bit long, please, so bear with me. You can see that Mega Software can be downloaded from the Chrome. I'm showing you how to download it. So you have to type on this Mega Software. The name of the web address of this is www.megasoftware.net. You have to type on this, click on this Mega Software. Then you have to click on download. Then there will be an agreement. You have to click on the accept, and automatically then you have to click on the country name, you have to click on the your student, you have to type on the kind of institution. So you have to click on the kind of institution means it's a university, you have to click on the university. Then you have to click on this, then download. As you can see, it will automatically get downloaded, and once it gets downloaded you have to click on the setup button and then it will finally get downloaded. Since I have already downloaded it, so I will not do this now. I will come to this Mega 11. I have already downloaded it. So this, so here we can see there are many options like align, data, models, distance, university, phylogeny, user tree, ancestors, selection, rates, clocks, disease. So we can see over here there is in align, you can edit build alignment means you can align a genetic sequence. If there are more than one genetic sequence, then you can align it, because it might be like not aligned, it might be farther away, so you can align it from this option. In data you can select genetic code table, select taxa and groups, and many more. Open a file session. In phylogeny you do you can construct a neighbor joining tree, construct maximum likelihood tree, construct test minimum evolution tree. Here when we see, you have to basically put the name of the file where you have the genetic sequence, name of the file name where you have downloaded the genetic sequence of a particular species. So you since I don't have any particular uh, file where there is genetic sequence, so I will not type here. So once you have the file, you can type here and then click on the open. So once you do that, right, once you do that, there will be a the phylogenetic tree will be constructed according to the genetic sequence you have given into the file, right? Whatever genetic sequence you have put, so there will be a this software, mega software, will basically uh, construct accordingly the phylogenetic tree of that particular organism, right? So now I will come to show you what is how to use the mega like what is the phylogenetic tree making. Like I will show you, right? Here you can see that the organism we are talking about is Streptomyces species. So there are many species we can see, right? Here there are many species: Streptomyces bacterium, CNQ, MAR2, MIX63, CNQ233. There are many species of Streptomyces itself. Now they all have originated from this ancestor, one ancestor which I am pointing here, right? From this ancestor they all have originated. Now in this phylogenetic tree we can see these two species, that is CNQ and MAR2. These two species are very near. That means that they are very similar genetically. They are very similar. They have same evolution. They have a almost genetically similar pattern, right? They're genetically very much similar. Now when we talk about these two and this, so these two means CNQ, MAR2 and M1X63. These three are genetically a little bit not very similar, because they are uh, far, right? We can see they are far. That means they are genetically not very similar as comparison to these two, right? So these are further, right? Again we can see over these three and this Streptomyces species CNQ233. These three and CNQ233 are more farther. That means these three species and CNQ233 are genetically more unsimilar, more not similar, right? So these three species, when compared to these, are genetically not very similar as compared to these two, that is CNQ and MAR2. These two are similar, but these when compared to CNQ233, these three are not very similar to CNQ233. Genetically they are not similar. In that way we can also say, in other words, that these have evolved bit earlier. These two, like CNQ and CNJ, they have evolved much earlier, and these, like CNQ233, Streptomyces species CNQ233, this species has evolved like they have evolved new, right? So they have basically evolved new when compared to Streptomyces CNQ140, MAR2 and M1X63. These three species, they have evolved when in comparison to CNQ233, these three have evolved earlier, and this CNQ233 have evolved much uh, just like few years back, means they have evolved new. right? Now talking about, uh, if we compare, suppose we compare these all these species, right? 1 2 3 till AW1, from CNQ 140 till AW1, these species, when compared to these two, MAR2 CNR 872, and this last one VIT, so these, in comparison to these these species till AW1, they have, see, we can see from the same ancestor these all have developed, right? But it depends that what the ones which are nearby, that means the branching is short, they have evolved, they are genetically more similar, and the ones whose branching is bigger, branching is long, they have genetically less similar, they are, means they have evolved new, and these whose branching is short, they have genetically evolved earlier, like, right? Now through this we can see, so through mega software we can analyze the phylogenetic tree, and it is helpful in determining which are genetically more similar and determining which are genetically less similar species from the same ancestor, right? So mega software helps in showing us the genetically who are more similar and who are genetically less similar, like in this evolution, right, from the same ancestor. Now so this we can see, this the a common ancestor, so many species have developed from here only, but these are more similar, means these have evolved earlier, and these are evolved later, right? These have evolved later, they have evolved just, they are new, right? So mega software helps in constructing the phylogenetic tree, as well as telling us who are genetically more similar and genetically less similar. We can analyze the evolutionary relationship of the different species, right, from here, from the same ancestor. Now let's go and look on to the this thing in alignment. As I told you, in this alignment, in align data, there was an option. You can see there are so many species. Now there are so many genetic sequences also, protein sequences, there are ATGCCA, ATGCCAT, so many protein sequences, genetic sequences are there of like thermotoga species. There are so many genetic sequences. So this app, basically from the align data app, align data tool, you can basically align the different genetic sequences. You can align it in a proper manner, right? If there is they are far away and they have not been aligned properly, of the same organism, different species are there, so you can align accordingly their genetic sequences. So one below the other, they can be aligned properly, otherwise you can get a lot of genetic sequences where the each of the organism species have different, they have the genetic sequences, but they are not one above the another, one below the another, means they are not aligned properly. They are, so you can definitely align the data properly through this mega software. Through which button? Through data align tool, you can do that, right? Now coming to, this is also another thing where you can align the data, right? Yeah. Now coming to mega software. Now here I have basically discussed the phylogeny and the alignment option. Now there are many more options like disease. Here you can diagnose the mutation. In clocks, you can compute time tree, rate correlation test you can do, right? In ancestor, you can infer the ancestral sequences, right? In user tree, you can analyze user tree by maximum likelihood and many more, right? But I have basically discussed about align. You can align the build, edit alignment. You can build the alignment of the genetic sequence you have been given. And here in phylogeny, you can construct the neighbor joining tree. You can do these also, like minimum evolution tree, maximum likelihood tree, and like that. In distance, you can see, you can compute overall mean distance, compute pairwise distances. In model, you can estimate substitution matrix, find best DNA protein models. In diversity, you can compute mean diversity within subpopulation, compute mean diversity in entire population, like that. Here in the below, we can see preferences, toolbar, mega links, updates. Here basically, in citation, you can give the citation, get the citation of the recent publication. In example, you can see the examples of recent publications, right? And many more. In here, you can see time tree, there are these options. So is the uh, overall thing, how to use mega software and what is its main main function. So that's it, and now you can close it. This concludes my video for today. I hope this video was quite informative and useful, especially for the students and researchers. I hope you liked the video. Thank you.